National Electrical Code Section 300.5 addresses conductors within the same enclosure. This section states that conductors of the same circuit, including grounding conductors, shall be permitted to occupy the same raceway, cable, box, or cabinet. This implies that neutral conductors belonging to the same circuit can be spliced together within an electrical box. However, a critical distinction exists when dealing with neutral conductors from different circuits. A general rule prohibits splicing neutral conductors from different circuits within the same box. This prohibition is rooted in safety considerations related to current flow and potential overloading. When neutral conductors from different circuits are improperly spliced together, it can create unintended parallel paths for current. This means that the current from multiple circuits could potentially flow through a single neutral conductor. This situation presents several risks. Firstly, it can lead to an overload of the neutral conductor. Neutral conductors are sized to carry the anticipated imbalance of current between the ungrounded, or hot, conductors of a single circuit. When carrying current from multiple circuits, the neutral conductor may exceed its capacity, leading to overheating and potentially a fire hazard. Secondly, improperly spliced neutrals can disrupt the intended operation of ground fault circuit interrupters, commonly known as GFCIs or arc fault circuit interrupters, known as FCIs. These devices rely on detecting imbalances in current between the hot and neutral conductors of a circuit. Splicing neutrals can cause these devices to malfunction, rendering them ineffective at protecting against electrical shock or arc faults. Thirdly, the practice of splicing neutrals from different circuits can also create voltage imbalances. Voltage imbalances can negatively impact the performance and lifespan of electrical equipment connected to those circuits. While the general rule prohibits splicing neutrals from different circuits, the National Electrical Code recognizes an exception for multiwire branch circuits. A multiwire branch circuit is a specific type of circuit that utilizes two or more ungrounded conductors, or hot wires, to supply power, sharing a common neutral conductor. These circuits are often used to provide 120 volts and 240 volts power in residential and commercial settings. The neutral conductor in a multiwire branch circuit is treated as a single conductor for the purpose of splicing. This means that the neutral conductors of different lengths, or phases, of a multiwire branch circuit can be spliced together within a box. However, it is crucial to ensure that the multiwire branch circuit is properly configured and installed to maintain safety and prevent overloading. When working with electrical circuits and wiring, it is essential to adhere to the National Electrical Code and local electrical codes. These codes provide detailed requirements and guidelines for safe and effective electrical installations. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical wiring or splicing practices. Improper wiring can create serious safety hazards, including electrical shock and fire. When dealing with electrical circuits, safety should always be the top priority. Understanding the rules regarding splicing neutral conductors is crucial for ensuring safe and reliable electrical installations. In summary, the National Electrical Code generally prohibits splicing neutral conductors from different circuits in a box, with an exception for properly installed multiwire branch circuits. This rule is intended to prevent overloading, protect against electrical shock and fire hazards, and maintain proper circuit operation. Let's delve deeper into the implications of this rule and the exceptions to gain a more comprehensive understanding. The prohibition against splicing neutrals from different circuits stems from the fundamental principle of maintaining distinct and independent return paths for current. Each circuit is designed with a specific hot wire or wires and a corresponding neutral wire to complete the electrical loop. When neutrals from different circuits are interconnected, it disrupts this carefully engineered system. Imagine a scenario where you have two separate 120-volt circuits, each powering different appliances. Circuit A powers a lamp and Circuit B powers a television. If you were to splice the neutral wires of these two circuits together in a junction box, the return current from both the lamp and the television would now be flowing through the same neutral conductor. This shared neutral conductor could become overloaded if the combined current exceeds its capacity. The ampacity of a conductor is its current carrying capacity, a maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. Overloading a conductor can cause it to overheat, potentially melting the insulation and creating a fire hazard. Moreover, the improper splicing of neutrals can interfere with the proper functioning of ground fault circuit interrupters. GFCIs are designed to detect even small imbalances in current between the hot and neutral wires of a circuit. This imbalance indicates that current is leaking out of the intended circuit path, possibly through a person touching a live wire. When a GFCI detects such an imbalance, it quickly trips the circuit, cutting off the power and preventing a potentially fatal electric shock. If neutrals from different circuits are spliced together, it can create a false sense of balance, preventing the GFCI from detecting a ground fault. This can leave individuals vulnerable to electrical shock hazards. Now, let's examine the exception for multiwire branch circuits in more detail. A multiwire branch circuit is a specialized wiring configuration that allows multiple 120-volt circuits to share a common neutral conductor. These circuits typically consist of two hot wires, each carrying 120 volts, and a single neutral wire. The hot wires are connected to different phases of a 240 volts power supply, ensuring that the voltage between them is 240 volts. The key to the safe operation of a multi-wire branch circuit is that the loads connected to each hot wire must be balanced. This means that the amount of current drawn from each hot wire should be approximately equal. When the loads are balanced, the current in the neutral wire is minimized. In fact, if the loads are perfectly balanced, the current in the neutral wire will be zero. However, if the loads are unbalanced, the neutral wire will carry the difference in current between the two hot wires. Therefore, it is crucial to ensure that the neutral wire in a multi-wire branch circuit is sized to handle the maximum potential imbalance in current. The National Electrical Code provides specific guidelines for sizing the neutral conductor in a multi-wire branch circuit. In general, the neutral conductor must be sized no smaller than the ungrounded conductors or hot wires. Additionally, if the majority of the load is nonlinear, such as electronic devices with switching power supplies, the neutral conductor may need to be oversized to account for harmonic currents. Harmonic currents are additional currents that are generated by nonlinear loads. These currents can significantly increase the load on the neutral conductor, potentially leading to overheating. When working with multi-wire branch circuits, it is also essential to use a common disconnecting means for all the hot wires. This means that all the hot wires must be disconnected simultaneously when the circuit is de-energized. This can be accomplished by using a double-pole circuit breaker or a switch that disconnects both hot wires at the same time. The purpose of the common disconnecting means is to prevent someone from accidentally touching a live hot wire while working on the circuit. If one hot wire is disconnected while the other is still energized, there is a risk of electric shock. In summary, the exception for multi-wire branch circuits allows the splicing of neutral conductors from different legs of the circuit, provided that the circuit is properly designed, installed, and maintained. The loads must be balanced, the neutral wire must be adequately sized, and a common disconnecting means must be used. It is important to note that the National Electrical Code is a complex and constantly evolving document. Electrical codes can also vary from location to location, so it is important to consult with a qualified electrician or electrical inspector to ensure that your wiring practices are in compliance with local regulations. Failure to comply with electrical codes can result in fines, penalties, and, most importantly, safety hazards. When working with electrical wiring, always follow these safety precautions. Firstly, always de-energize the circuit before working on it. This can be accomplished by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Secondly, wear appropriate personal protective equipment, including safety glasses and insulated gloves. Safety glasses will protect your eyes from debris, and insulated gloves will protect you from electric shock. Thirdly, use only approved electrical tools and materials. Make sure that your tools are in good working order and that the materials you are using are listed or labeled by recognized testing laboratory, such as underwriters' laboratories. Fourthly, never work on electrical wiring in wet or damp conditions. Water is an excellent conductor of electricity, and working in wet conditions significantly increases the risk of electric shock. Fifthly, if you are not comfortable working on electrical wiring, hire a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals if you are unsure of what you are doing. In addition to the general rules and exceptions regarding splicing neutral conductors, the National Electrical Code also addresses other related issues. For example, the code prohibits the use of the neutral conductor as a grounding conductor for equipment. This means that the neutral wire cannot be used to ground metal enclosures, such as electrical boxes and appliances. Grounding conductors must be separate and distinct from neutral conductors. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source. This allows the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and de-energize the circuit in the event of a ground fault. If the neutral conductor were used as a grounding conductor, it could become energized during a ground fault, creating a shock hazard. The National Electrical Code also addresses the issue of identifying neutral conductors. Neutral conductors must be identified by a white or gray color. This allows electricians to easily distinguish neutral conductors from hot conductors, which are typically black or red. The white or grey color is intended to prevent accidental connections between hot and neutral wires, which can cause short circuits and other problems. In conclusion, the National Electrical Code provides comprehensive guidelines for splicing neutral conductors and other electrical wiring practices. These guidelines are intended to ensure the safety and reliability of electrical installations. By following the code and taking appropriate safety precautions, you can minimize the risk of electrical shock, fire, and other hazards. Always remember to consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical wiring. Electrical safety is a serious matter, and it is always best to err on the side of caution.